Hello, everyone. My name is Jared Costello. I am a senior here at the University of North Texas, studying data analytics. I am working under Professor Deepak Pravin, along with Anna Robinson. My research was with the CIRI Cyber Talent Bridge. The Cyber Talent Bridge is a tool that empowers businesses to map out various knowledge, skills, and abilities for each employee that are required to perform certain cybersecurity tasks and need to protect their business. So our challenge was to provide a better matching algorithm for the Cyber Talent Bridge to use these various task knowledge, skills, and abilities from the NICE cybersecurity framework to the NIST 800-53 controls in order to make the Cyber Talent Bridge a more accurate system in matching these things to each other. We focused on creating relationships between the NICE framework tasks, knowledge, skills, and abilities to the controls within the NIST 853 publication. So our team's approach was to split the work between the task, knowledge, and skills in the NICE framework, with one member of the team working on the task, while the other was focused on the knowledge and skills, and they evened out. The NICE framework also includes abilities, but they have been depreciated in the most current version of the framework, which is version 1. So this basis of my poster is on the tasks. So my first approach to matching the tasks to the given controls in the 853 was to use a thing called k-means clustering. This aims to cluster an X amount of tasks into a Y amount of clusters. My second approach, or our second approach, was to use a cosine similarity measure. This measures the similarity between two vectors and assigns a value of the similarity between 0 and 1, with 1 being the closest, almost verbatim, for similarity. Our last approach was to use a similarity sequence matcher, and this measures the similarity between the words of two strings and the sequence in which they appear. So in the middle, I have some of my outcomes and results. First, I have my cosine similarity. As you can see, AC2 is the control that I was working with, and it shows a 1.0 in green right next to it because it's being compared to itself. Everything else after that is the top 15 tasks that match with the AC2 control, the highest scoring. The closer to 1, the more similar it is to the AC2 control. AC2 is known as account management, and the T0144, which is the highest rating, is known as managing accounts, network rights, and the access to systems and equipment. So I believe it matched up pretty well with this. It came out with fairly accurate results, in my opinion. The next thing I tried was a similarity sequence matcher. These are the top 15 similarities that were compared to the AC2 control. Three of these similarities from my results came out and were already in the AC2 control in the Cyber Talent Bridge. It worked well. It just didn't work as well as the cosine similarities matcher, so I gave a little less of a rating. So we tried that. We also tried another thing called k-means clustering, but we ended up not using that because it was unstable. So in conclusion, our team ran 3 different tests on our data known as cosine similarity clustering and a similarity sequence matcher, but we decided that our top 2 clustering tests with the highest accuracy were the cosine and the similarity sequence matcher. Through these 2 clustering tests, we can better the Cyber Talent Bridge tool and provide a more accurate list of tasks, knowledge, skills, and abilities for each given control in the Cyber Talent Bridge. Our team also tried to use k-means clustering in order to sort various task, knowledge, and skills and abilities, but we concluded in our results that it was too unstable when using it, for the fact that when we decreased the amount of clusters, the same task did not stay with the same control. I'd just like to thank everyone who supported me through this and for this opportunity. Thank you.